It means we have very large pores on the surface. Even the endothelial cells are not connecting somewhere. So we have very, very large pores, as you are seeing here. These are pores. It's non-continuous, it's discontinuous or non-continuous. And through these holes, not only the molecules can pass, but the cells, even RBCs and white pieces can pass through it. We have this type of capillaries in some tissues, such as bone marrow. In the bone marrow, the stem cells produce RBCs and white pieces from blood physiology, and they should pass through these holes and circulate in the blood. So you are seeing this type of capillaries in that tissues. For example, we have this type of discontinuous capillaries in the liver. Yes, because in the liver, imagine that most molecules are absorbed by intestine. After eating, the molecules in the intestine absorbed by the capillaries, and these molecules are going to the liver for analyzing and for changing. So in the liver also we are seeing some types of discontinuous shape. So based on permeability, my dear friend, we can see different types of capillaries in the circulatory system. And in the brain, my friend, in the brain, these continuous or not permeable capillaries produce a kind of barrier in the nervous system. You will see it named blood-brain barrier. Blood-brain barrier, abbreviated as BBB. We have a barrier which is produced by this type of continuous tightly connected endothelial cells as a blood-brain barrier.
The GLUT1 we have, I think, a gate which is called GLUT1.
Yes, it's a transporter.
Yeah.
Yes, it's on the surface.
Yeah.
It means that they can only transport glucose, not any other proteins or agents. Any question? So, the main topic that be sure that I have one question in the final exam is now that the thing that I'm going to talk with you. So please pay attention. If you understand it, it's only a mathematics of differences of some digits. You can easily find the answer. So take a deep breath. Don't blame me. Okay, so let's see what happened in the capillaries. Until here, we are seeing some structure, histology, and anatomy. The important part is in here, and in the comprehensive exam, in the final exam, I am completely sure one question in circulatory system regarding this part. Okay, so please try to understand it. If you understand it, it's super easy for you. Boys, at the end of class, I'm talking to you too. Please try to concentrate, okay? Okay, so, my dear friend, we should exchange gases and nutrients in the blood and tissue in the capillaries bed, okay? So, when I'm talking about exchange, what happened? We have a blood. So, the blood should exchange gases and molecules with the interstitial fluid. And on the other hand, there is an exchange of fluid and gases between interstitial fluid and tissue cells. interstitial space and fluid is meaning the parenchyma of any tissue, yes? Interstitial space, you know, the tissue has some spaces that there is no cells, like parenchyma or interstitial fluid. We have a fluid in the tissues. So the first thing, if we diffuse gases and molecules between blood and interstitial space, the interstitial space and cells simultaneously can diffuse with together. Okay, so our topic in this gases and nutrients exchange is exchanging of nutrients from blood and interstitial space. Okay, so blood and interstitial space is must be exchange gases and nutrients. So at first, let's think about some forces. Please pay attention to me. We have one force in the capillaries. In the capillaries, because we have blood, and from physics knowledge, we know that blood has a hydrostatic pressure. Yes? The hydrostatic pressure that makes by any fluid such as blood. What is the hydrostatic pressure? Hydrostatic pressure trying to push blood into the wall of vessels. Yes? They're trying the push of blood into the wall of vessels. It means that hydrostatic pressure trying to send plasma of blood to the interstitial fluid. Yes? The arrow, the arrow of forces of hydrostatic pressure is sending blood to the interstitial fluid. Yes? Clear? Yes. Okay. So, again, inside the blood, my dear friend, we have another term, another force named colloid pressure. Let me show you by picture. So, imagine this is a vessel tube with the capillaries. Imagine this is a capillary. Inside the capillary we have blood. So we have one force of blood named hydrostatic pressure that trying to send blood to outside of the capillaries. It means trying to send blood into the interstitial space named hydrostatic pressure of capillary. Yes, this is hydrostatic pressure of capillary because of the fluid in the and blood is considered as a fluid. And in the interstitial space, again we have a fluid too. So we can say we have another hydrostatic pressure that trying to send fluids from the interstitial space into the blood in this point arrow, named hydrostatic pressure of interstitial space. Because in each tissue we have fluid. So we have two hydrostatic pressure that are against to each other. One of them trying to send blood from the capillaries into the interstitial space. Another one trying to send fluid from the interstitial space into the capillaries. They are different from each other. Obviously, the digit of each pressure is more than another one. It means that the fluid are on the higher forces, higher pressures. Okay?
So the net is zero?
No.
The net because it is in different directions?
They are different directions, but the summation is important for us, yes?
Okay.
For example, if hydrostatic pressure is 20 and the hydrostatic pressure of interstitial fluid is 5, the pressure is 15 milliliter of mercury from the capillaries into the interstitial space, the summation.
For example, if there is 20 and 20,
Yes.
so it's 0, so it's not fair.
It's not zero.
No.
If it's equal, yes.
Yes.
There is no movement of fluids between two spaces. But it's not zero. Always in our body it's not zero. So we have two hydrostatic pressure with two different arrows in the capillaries and interstitials. The next thing, my dear friend, in the capillaries and in the interstitials, both of them you can see the next course, we have proteins, we have electrolytes, we have some molecules. From our basic knowledge, I think we know that we have osmotic pressure, and if the number of molecules in any part is increased, the osmotic pressure in that part is increased too. Are you familiar with osmotic pressure? Yes? Osmotic pressure related to the number of molecules in any area, in any surface or any cells. If the osmotic pressure increase, it means that the tend to absorb water is increased. Yes? Do you understand from in the high school osmotic pressure? Yes?
Yes.
Okay. So in our body, the osmotic pressure that mostly produced by the fluids is because of proteins. Proteins produce osmotic pressure. So anytime that proteins produce osmotic pressure, we set as an oncotic pressure. Oncotic pressure, anytime you hear oncotic pressure, anytime you hear oncotic pressure, you have to know it's the osmotic pressure related because of proteins. Proteins produce that pressure. So we have oncotic pressure of capillary. Pressure of capillary. Obviously, this oncotic pressure trying to absorb fluids from the interstitial space into the blood. The arrow you are seeing into the blood, oncotic pressure. Again, we have oncotic pressure of interstitial fluid. In the interstitial space, we have a little proteins, and we have oncotic pressure of interstitial space. Again, this oncotic pressure must absorb from the capillaries into the interstitial space. So, as you are seeing, we have 4 forces that 2 by 2 are different together. Yes? And in the exam or in any questions, we have one question regarding this. In the questions, they give you digits for pressures, oncotic pressures of the capillaries, oncotic pressures of the interstitial space, hydrostatic pressure of the capillaries and interstitial space. You have a digit and you have to summation, mathematical summation of each pressures, and finally find the final pressure is up from the capillaries or into the capillaries. Is out of the capillaries or into the capillaries. Okay? The summation of these 4 pressures. Clear? What about my beautiful girls? Clear? Okay. If it's clear, let's complicate it a little. My dear friend, the hydrostatic pressure in the interstitial space is not positive. It's negative. What does it mean? It means that the pressure is negative and this arrow is going to this way. It's negative. All pressures we are talking is positive, but this pressure is negative. It means that not only hydrostatic pressure of interstitial fluid cannot send fluids into the capillaries. They're trying to absorb water from the capillaries. It's negative. So the arrow is in the out of the capillaries. As you are seeing here, the hydrostatic pressure of capillaries trying to send out from the capillaries. The hydrostatic pressure of interstitial fluid trying to send out from the capillaries. The oncotic interstitial space trying to send out capillaries. The only and the last one pressure that is against another is oncotic pressure of capillaries. All of three is sending out of the capillaries. Oncotic pressure only trying to absorb into the capillaries. From now, sending fluids out of the capillaries, let's say filtration. Sending fluid out of the capillaries is named filtration. From now, when we talked about filtration, we know that sending blood out of the capillary and absorbing of fluid by capillary named reabsorption. Reabsorption. Okay, we are talking about two forces, out of the capillary and into the capillary. And I told you that from now, the sending of fluids out of the capillary, we said filtration, sending fluid out of the capillary, and absorbing of fluid by the capillary, named reabsorption, into the capillary, named reabsorption. Okay? Negative. I told you that hydrostatic pressure, you mean, maybe I tell you that it's 3 millimeter of mercury. Okay? Hydrostatic pressure. Is it logic to you? And I'm telling you that it's not positive, it's negative. We add -3 near to it. It means that it cannot send fluid into the capillary. It's minus, it's suction. We have a suction of fluid from the capillary. It's negative. Okay? So let's solve this summation by an example. Imagine the hydrostatic pressure of capillary is 30 millimeter of mercury. Can you calculate it? The hydrostatic pressure of capillary is 30 millimeter of mercury. The oncotic pressure of capillary is 28 millimeter of mercury. The oncotic pressure of interstitial space is 7 millimeter of mercury. And the hydrostatic pressure of interstitial space is -3 millimeter of mercury. Can you calculate the final pressure? And the final pressure is filtration or reabsorption. Only mathematics summation of these pressures. You can add the same pressure with same direction and reduce it from the pressure against them. Filtration. Let's wait for your friend. Please calculate it again. How much? The pressure? 62. Please calculate, think about more. Add same directed pressures with together. We have 3 pressures with same direction into filtration. Add filtration pressures, reduce it from the reabsorption pressure. 34. 12. 12 into the filtration or reabsorption? Filtration. Please think about it. The answer is 12. Think about how they calculate the 12 as a filtration. Do you find the answer? Agree with 12? No? Can you come write your calculation on the top of the board?
Plus 7 is 40.
Yes,
Right.
minus is 40 minus
40 minus
28
28 is it 12
as a filtration.
as filtration.
As it the same. Yes, thank you. Thank you. Minus 3, it means that I told you. Do summation for same arrows. Minus 3, it means that the arrow is upward. It's a filtration. Minus 3, when I'm telling you that it's a minus 3, it means that is a filtration. Okay? So find which force are filtration, do summation of all these 4 pressures and reduce it from the reabsorption one. Let me give you another one. Let's say hydrostatic capillary pressure is 10, it's 28, and here it's minus 3, and here is 8 millimeters of Can you calculate and tell me the answer of this one? 7 to reabsorption. Do you talking together or calculating? Calculating, good. Yes, yes. Can you come? Right. Please listen, my dear friend.
البريشر مال الكابيلاري فهو بالبداية راح نقصر نحسب القانون بالبداية فاحنا الضغط اللي يكون داخل الشعيرات وهنا الضغط اللي راح يكون داخل الانسجه وهذا الضغط الازوموزي هم داخل الشعيرات وهذا داخل الانسجه فبالبدايه نقص نقول 10 ناقص ماينس 3 ناقص 28 ناقص 8 فهنا راح يكون 13 ناقص 20 فالناتج راح يكون سالب 7.
Thank you. Thank you. Your friend used formula in the slides, but if you find the filtrations, pressure, and reduce it from the reabsorption, it's okay. In both way, you should find the final answer. Okay? You can use the formula in the slide, or you can find the same direction pressures, reduce it from the another one. So, generally, my dear friend, if we reach to the minus pressure, we consider it as a reabsorption. If we have a plus or positive pressure, we consider it as a filtration. Okay, so these two are considered as a filtration, as a positive. If it's negative, it's reabsorption. Please, can you see the only opposite pressure in here? Can you tell me what is the only opposite pressure in this capillaries exchanging? Opposite pressure, oncotic pressure of the capillaries. So, because it's only opposite pressure, it means that this pressure must be so important for the final digit. If it's a little increase or decrease, it has a huge impact. And we have many situations that this pressure change. It means that if this oncotic pressure reduce, I am telling you that always filtration increase. Yes? If the oncotic pressure reduce, the filtration pressure will be increased. Filtration pressure means that most of plasma are passing from blood into the tissues. On the other way, in clinical term, we said